任中心开幕的演讲贵宾。以太坊目前是全球仅次于比特币的最大数位货币与区块链平台。以太坊主要的创办人是今年22岁神童 Vitalik Buterin， 他也是以太坊平台的首席科学家。他今天的讲题为“以太坊区块链技术所见之金融服务应用平台概观”。We are very honored to invite the inventor of Ethereum, Vitalik Buterin, to deliver the keynote speech for our opening ceremony. The title of his speech is A Survey of Ethereum Application in the Financial Service. Without further ado, please welcome the inventor of Ethereum, Mr. Vitalik Buterin.
Thank you everyone for coming, and I hope that this event and Taiwan's efforts in promoting blockchain technology continue to be a great success. So what I was asked to talk about today is basically the current state of Ethereum applications. So what kinds of things people are using Ethereum for, what kinds of things Ethereum blockchain technologies generally can be used for, how these different applications might interact with each other. So the platform was originally released back in 2015, last year in July. The idea for Ethereum first came in 2013, when people were starting to realize for the first time that blockchains were usable for more applications than just money. And at that time, people were starting to realize that you could use blockchains for financial contracts, for crowdfunding, for voting, for registering various kinds of digital assets. And the goal of Ethereum was to try to be a general purpose platform, a blockchain that doesn't just try to target one single application in the way that, for example, Bitcoin just targets money, but try to be a platform where there's one platform that could be used for potentially many different things. It including various kinds of financial applications, including non-financial applications, and also what I call semi-financial applications. So right now there's about 300 of these applications live or being developed in various different areas. Some of them are being done by startups, some of them are being done by banks. There's a couple of pilots that are even being done by governments. The Bank of England has an internal pilot doing some things with Ethereum. Some of them are being done by collaborations between different groups. Some in finance, some in areas like Internet of Things, data storage, computation, identity verification, payments, financial contracts, insurance, digital assets, exchanges, prediction markets. And I think initially the majority of the applications that people were thinking about, not even just in the Ethereum space, but in blockchain technologies generally, are financial applications. I mean, even the very first application, Bitcoin, is just a simple payments application. And after that, people were thinking about financial contracts, crowdfunding, digital assets. More recently, there has also been increasing interest in non-financial applications. So these are applications that use blockchains and use their ability to keep track of data, to provide cryptographic proofs and cryptographic audit trails of what happens and what people did for things such as identity verification, supply chain tracking, DNS, certificate revocation, intellectual property management. And so some of these applications, I mean, they all don't have anything to do with money directly. That said, some of them are still useful for the financial industry. Look at identity verification. By itself, has nothing to do with money, but KYC is one of banks' biggest challenges today. Look at certificate revocation, DNS, internet security. We just saw the internet get attacked last week in the US. Huge number of sites went down. Ethereum blockchain, Bitcoin blockchain, running through the whole time with no problems. Decentralization didn't solve real internet security issues. And that's if we want to create the open financial networks of tomorrow, then security is something that will no necessarily needs to look at. The most interesting applications, a lot of them are semi-financial. They include some components that have to deal with finance, some components that have to deal with money, as well as some components that use blockchain features for other applications. IoT payments, one of them is one, and we'll talk about some applications of that later. Data storage, computation markets. Imagine something like a decentralized Amazon AWS, where not all the computation happens on the blockchain, but where payments are done on the chain, computation is verified on the chain, electricity trading. So lots of different things, large and small, in many different areas. So we'll start off with the simplest application, digital assets. So as I said before, first application of blockchain technology is Bitcoin. It's a digital asset. Now, since then, we've come to realize that there are different kinds of digital assets. There are digital assets, things like Bitcoin, things like Namecoin, Ether, assets whose existence is defined only by the networks that these assets are built on top of. But at the same time, there's also another kind of asset, digital assets that represent something in the real world. And even those have different categories of them. We can look at fiat currencies, we can look at gold, we can look at company shares. I mean, we can even look at assets that aren't fungible, that aren't like currencies, where there's different kinds of tokens and each token only has one unit of each one. Even something as small as items inside of video games to something like land property rights. So what exists today? At our annual developer conference in September, Santander, one of the largest banks in Europe, announced a project that would create a digital token that would run on top of the public Ethereum blockchain, where each unit of this token is backed by a dollar, a euro, a British pound, some other currencies in your bank accounts. So, just by itself, what this basically is a different way of holding money. You can think of it as a different kind of bank account, one where the technology that you use to interact with it is updated to the 21st century. Where, if you want to send money, you can send money exactly as easily as the experience is with other kinds of cryptocurrencies, with payments inside of video games, with this digital payment media that we're already used to. But the more interesting applications of this come when you actually do start to combine these applications like this as a basic building block with some of the other innovations that blockchains and Ethereum and smart contracts have to offer. So, one simple example, and this is actually one of the examples that I always use in my developer training examples, something like escrow. So, simple problem, if I'm trying to sell something, if I send the product first, how do I trust that you're going to pay me? If you pay me first, how are you going to trust that you send the product? So, using smart contracts, there's this interesting solution that called 2 out of 3 escrow, where basically what happens is I first send a payment to a smart contract, then you send the product, and if everything goes well, I send a transaction, I send a message to the smart contract, and the smart contract processes this message, and this means that you can withdraw the funds that I sent you. If the product does not reach you, then I might decide, okay, I admit it's my fault, and I might send a message to the smart contracts that refund money. What if the two of us disagree? Then there might be some third-party arbitrator who decides. But what if the third-party arbitrator is corrupted? We've had third-party escrow providers before, but it turns out with smart contracts, you could actually create a system that's robust even if any one of the 3 parties is compromised. If the arbitrator is corrupted, if they get hacked, if it turns out they're untrustworthy, they can't steal the money for themselves. The only kind of message that they can send to the smart contract is to either send the money to the sender or send it to the recipient. So this is just one nice application of smart contracts to reduce the amount of trust needed in business interactions. Now, how does this fit together with fiat currency-backed tokens? Now, the answer is this. Well, in order for this kind of application to work, you need to have some kind of digital asset that the smart contracts can hold on to. Now, there have been people that have built services where the smart contract holds on to Bitcoin or holds on to Ether. The problem if you do this is price volatility. These cryptographic digital tokens, they have this benefit that, or at least the digital tokens that are just sort of exist purely in cyberspace, that are not connected to anything in the real world. They have the benefit that they have no counterparty risk, but they have the cost that they have a lot of price volatility. And so I might send $10, but by the time it comes to confirm the transaction, the $10 became $12 or became $6. If you have smart contracts where the smart contracts are able to directly hold euros or dollars, maybe time $1, then all of a sudden you have an application that provides real value, but at the same time where that doesn't require users to learn about any new kinds of digital assets, that doesn't impose price volatility, and you have something that people can actually use and that actually starts to provide a lot of benefit. Going beyond fiat currencies, gold. If people want to invest in gold, or people want to use gold as a kind of payment medium for whatever purpose, there's a company in Singapore that's putting gold on the Ethereum blockchain as well. There's also many other kinds of assets, and we'll get into some of those later. There's projects that are trying to put various kinds of company shares. They're trying to create assets that people can invest in. There's actually quite a lot of different examples. So here's a company that's out of Taiwan, and Alex is fortunately here to represent it today. Basically trying to use blockchains to create a kind of multilateral payment system. So one of the things about Taiwan that's, I think, is both an advantage and a challenge is that finance and many other industries, they're not as centralized into one particular company that has either a monopoly or that has a very large market share. Look at China, everyone uses WeChat, everyone uses Alipay. Here, not so much. So when you have industries that are decentralized like this, one benefit is you have more competition, but one risk is that you have a lot of different platforms, and these platforms have to talk to each other. And if someone wants to make a payment from one to another, then it becomes inefficient. And this is something that actually happens in international finance as well. If I want to make a payment from one bank to another bank, you have to reconcile a lot of different databases. Settlement often takes 3 days. Process is often not even fully automated, has high fees. So what solutions like this are doing is they're saying, well, what we can do is we can have all these different banks, all these different providers sit on a common blockchain platform, where the platform is not owned by any one of them. So the infrastructure can't be converted into a tool to allow one company to gain some kind of monopoly advantage. But at the same time, by having different companies collaborate together on this one database, we can really reduce costs, we can really increase efficiency, we can make a system that's almost as efficient as if there was one company running the whole thing, without having one company running the whole thing. And I mean, if you do this, and if you automate the whole thing, then you can increase the efficiencies of payments by potentially quite a huge amount. Now, this is one story, and this is a story that's actually replicated in other situations as well. So let's take a look at Clearmatic's settlement coin. So this is, by the way, both this and me and Clearmatics, both on Ethereum-based consortium chains. So permission ledgers that are based off of the exact same currency, Ethereum public chain. What the settlement coin is doing is it's trying to do a similar story for financial derivatives clearing and for collateral in financial contracts. So the story here is settlement coin is a kind of asset that exists inside of this ledger, where that asset is almost directly backed by central bank money. It has almost no counterparty risk except for the kind of obvious counterparty that is the central bank itself. Now, what does this asset then can be held inside of smart contracts, and inside of these smart contracts, the asset can directly serve as collateral for financial derivatives. The way that the financial industry, the way the regulatory situation is evolving in the UK and in other places is that collateral requirements are going up, and in many cases, both sides of a transaction have to post collateral now. But one of the problems is, how do you manage all of it? How do you see where all the collateral is? How do you make sure that collateral is not being used twice for different contracts? And putting everything on a single blockchain and having the collateral actually be directly controlled by the smart contracts, and is one interesting way of solving the problem. You don't need to have central clearing parties. You don't need to have complex systems where you have many bilateral links between every single pair of financial institutions. You can have large number of companies share a common ledger, and on that common ledger they can interact with each other almost as efficiently as though they were interacting through a single server. So in terms of financial efficiencies, in terms of increasing trust, in terms of enabling collaboration, in terms of making industries more inclusive and more friendly to these more kind of multilateral ways of doing things, this is a really huge improvement. UBS has a project that they call a Smart Bond, where they are basically trying to track the entire life cycle of a bond on an Ethereum-based blockchain. Buying a bond, paying coupons, settling, basically the entire process. So now, as I understand, what they're currently doing is they're working with some NGOs in Africa to try to implement this technology for social impact bonds. So, insurance. So if we go outside of simple payments, if we go outside of financial derivatives, insurance, another important piece of finance. So one of the reasons why financial contracts are so suitable for blockchains is because blockchains operate in this world of numbers and math. And financial contracts, to a large extent, are numbers and math. In the case of insurance, it's actually pretty similar. It's I pay $20 to buy an insurance policy. If some event happens, then I automatically get back up to $1,000. Now, in some cases, it's a bit more complex. In some cases, like health insurance or house insurance, you have to determine what the level of what the amount is that you have to pay back. It starts to get very complex. In some cases, it's actually quite a bit simpler. So this is flight delay or flight cancellation insurance. So this application is basically one where you can buy an insurance package which basically automatically pays you some amount of money if a flight gets delayed or if a flight gets canceled. This is something that's actually very easy to implement on a blockchain because what you need, whether or not a flight was delayed, whether or not a flight was canceled, it's just data. And it's data that can be pulled from common, fairly publicly accessible APIs, and which can be verified fairly easily, and which can be executed almost automatically. So what this application did is it basically just made a contract on the Ethereum blockchain. It used a service called Worklies that allows contracts on the Ethereum blockchain to talk to APIs on the internet, and it created a smart contract which basically says exactly what I mentioned. Party A puts $5 into the smart contract representing a policy, and if a particular flight gets delayed, then the contract automatically pays, let's say, $500 to party A. Fairly simple, just logic and just math. Now, there are some forms of insurance where this is not very useful. There are other forms of insurance where this actually can work quite well. Anything to deal with hard numbers, flight delays, weather, prices. Another interesting application in this general kind of theme is actually mutual insurance. So if you look at the way that the insurance industry evolved, one of the oldest forms of insurance didn't actually have a separation between insurance companies and insurance buyers, where you would have people buying a policy and then the company would pay back. What you had is something much simpler. You would have 10 ship owners all sign a contract and agree, and basically say, if a storm or pirates or whatever destroys or steals one of our ships, then the rest of us all pour money together and pay for it. And now, this kind of model did fall out of fashion, and I would say in large part because once you have complex economies, once you have large numbers of participants, it just becomes less efficient to do this in a decentralized way and more efficient to do it through centralized insurance companies. But with the benefit of modern information technology and with the benefit of blockchains, maybe we can actually take a second look at these older approaches, and maybe we actually can come up with ways where people can insure each other, and maybe this model actually is something that could be applied in places where insurance currently doesn't work that well. Maybe this is something that in emerging markets could potentially be quite useful. There's a company based in California that I met last week that's actually working on software for rotating savings and credit associations on top of Ethereum. So, in general, these methods for people of interaction that work well in small groups, but that just have too much complexity to manage in medium-sized groups. Perhaps blockchain technology can give them a sort of 21st century twist. Prediction markets. So this is this general idea that people can kind of bet on whether or not certain events will take place. You can have a token that pays out $1 if some event happens, pays out nothing if the event doesn't happen, and you can have a market on a blockchain, and the price of that market reflects the probability that the market thinks the event will take place. This is something that there's already a few projects on top of blockchains that are doing this, and in general, this is actually something that academics have been researching for the last 10 or 20 years, and in many studies, they've actually shown that this is pretty accurate, a pretty accurate way if you let enough people participate at predicting the probabilities that different things will happen. Now, blockchains are a fairly ideal platform to actually try something like this out. Corporate governance. So here's a very interesting one, and here's one that's actually already live and that already has over 100 customers. So there's a company based in Singapore called Autonomous. By itself, Autonomous is basically just a corporate registrar. It's a company that you can use where through them you can sign up, you can register a company. They do the job of registering the legal entity, they do the job of getting a bank account. But then after that it gets more interesting. If you register a company through Autonomous, then they have an Ethereum-based platform where you can do basically any corporate governance task on top of the blockchain. You can vote on resolutions on the blockchain. You can transfer shares on the blockchain. You can appoint directors on the blockchain. And blockchain becomes a sort of audit trail, a cryptographically secured audit trail of every single thing that happened. So, instead of doing all of these processes by creating, signing forms, writing these paper signatures that are actually extremely easy to forge if anyone cared to, like dealing with complex manual processes that take weeks. Everything can just happen on blockchain, and there exists this unalterable cryptographic record of everything that took place. And some of the more interesting benefits even come when this gets combined together with other blockchain applications. You can imagine sending shares of a company into a contract where the smart contract automatically does equity crowdfunding. Automatically sends, let's say, 1 share to anyone who sends in 1,000 units of Santander-backed Singapore dollars. If he wants to have regulatory compliance, well, you can throw in another blockchain application, and you can require people to use all the same chains to verify their identities. So there's one, if you can combine blockchain applications in different ways, then the number of possibilities multiplies. Music. So here we can start to move from just narrowly financial applications to how some of these things can improve things in wider society. So if you look at music industry in general, it's something that right now is fairly opaque, and I would say is not very friendly to the people that actually produce the songs. Basically, if he wants to get anywhere, you have to sign a contract with some major record label, you have to give up a very large share of your future income, and quite often you don't even get any statistics of, or very bad statistics 1 or 2 years later down the line, of how many people are listening to your songs, from where, how much revenue you got. So there's a platform called Grucho, which is basically trying to change that and trying to flip the model. So the way that Grucho works is basically that anyone can sell music on top of it, anyone can buy it, and you can use a smart contract to determine automatically on the chain in a transparent way, determine like where the money goes to. So you can have a contract that says 100% goes to me, or you can have a contract that says 70% goes to me, 30% goes to the producer. So the point is that realistically, people are going to want to give up some percentages of their revenue in exchange for making the music higher quality, doing promotion, doing marketing, getting the music out more. But it's up to the musicians themselves, and they're the ones that are in control of how that happens. So this is a project that's been kind of in development for about a year. There was one sort of brief pilot last year where a kind of semi-famous British singer named Imogen released a song on top of it. So not really out yet, but it's moving forward. Identity verification. So this is another non-financial application, but it's one that I would say here both financial institutions and many other kinds of users really care about. Identity is, we often think about it in very narrow terms, but it's actually something that's very fundamental to a very large portion of our interactions. Identities include things like passports, phone numbers, email addresses, social media accounts, Twitter, Facebook, WeChat, arguably even your face is an identity that you use in person. The need to be able to prove that the person who sent one message is the same as the person who sent another message is fundamental. Without it, we basically can't have trust. So one of the problems is, though, is that a lot of our identity solutions so far are either fairly ad hoc or fairly inefficient, or on the other side, fairly centralized. So if you look at just how identities on the internet evolved, for example, started off with every single online forum having its own system of accounts. And if you want to be on one forum, you need an account there. If you want to be on another forum, you need an account there. If you want to be on a third forum, you need an account there. Then the number of services multiplied. And then people started realizing that each user having to memorize 100 passwords and keep track of 100 usernames isn't really viable. And so the system sort of moved on over to this paradigm where you have to sign in with Google, sign in with Facebook, sign in with Twitter, sign in with whatever other service. And this does alleviate the problem, but at the same time it creates this environment where Google and Facebook and Twitter and so forth basically have the backdoor keys to your online life. And these identities are not useful everywhere, so banks don't accept Google and Twitter accounts. Now, in the case of banks, you have a different problem. You have the problem that if you want to set up an account with one bank, then they need to verify a large amount of information. They need to go through AML checks, go through KYC checks, and after a process, which often takes quite a bit of effort, you have an account. What if you want to go to another bank? Well, you have to go through the exact same process again, and after exactly the same amount of labor, you have another account. What if we can flip the identity model around? So, for the last few years, and I would say even longer, there have been people that are working on a different model of identity that they call self-sovereign identity. So, the way that self-sovereign identity works is this. Start off with every person having an identity, and that identity is basically a cryptographic key. And the identity is something that they control themselves. It's not an identity that's dependent on any other organization, not dependent on Google, not dependent on any government, not dependent on any bank. This is what they use to interact with different services. On top of that, you can have different entities provide attestations, provide claims that say, this person has a particular phone number, this person lives in a particular country, this person has at least 95% positive feedback on e-commerce websites, this person is a citizen of some particular country and has some particular name. Then these attestations, they're not fully public. They're not something that like everyone can see because that would compromise too much privacy. But they are kind of committed to, they are kind of hashed into this record of intent. And if someone wants to interact in some way, and let's say the bank wants to verify that they're a citizen of some country, or they want to verify some facts about themselves, they might want to get some ratings to determine how trustworthy the person is, then the user has the ability to voluntarily reveal any of these attestations. They can reveal the fact that, oh, this other bank has already verified me, or that, oh, I have these relationships with these 200 people, or that, these other people certify that I am some particular person. And the person's free to provide these attestations, and then the bank verifies them, or the user verifies them, and determines whether or not they're sufficient. So with this kind of model, each individual's identity doesn't need to rely on any one single provider. But at the same time, you get a lot of benefits because you don't need to duplicate as much work. A person does not need to have and maintain a separate account at every single service that they use. If a person wants to open up new accounts, they don't need to have the same information get verified every single time. So it's a model that I would say is both more inclusive and more efficient. And it's one that can work on sort of all levels of the scale. It can work for online identities and sending messages online. It can work for banks. It could even work for financial inclusion applications in the third world. And there are people that are trying to do this. So there's different pieces of the identity puzzle. So two of them here. This one on the left is a proof of phone number. So it's basically a protocol where what you can do is you can submit an Ethereum address, you can submit a phone number, and it sends a confirmation code to your phone number, and if you confirm it, then the service automatically sends a record to the blockchain that basically says, yes, this account does have some particular phone number. On the right, you have something that's also more fairly interesting. So Estonia has this program that they call e-residency. And the idea basically is it's a kind of ID card. And it's an ID card that you can use for very many different things. So inside of Estonia, you can use it to open a bank account, you can use it to interact with government services. And in the EU, I believe as of next year, it'll actually be a legally enforceable way of signing documents. Now, one of the nice things about the e-residency program is that actually anyone in the world can apply for one of these. So anyone in the world can apply to have one of these cards. And then if they receive it, then it becomes very easy for them to set up companies in Estonia. So what one developer in London did is he actually created a bridge where that automatically verifies that a particular user digitally signs a message with one of these e-residency identities and automatically links an Ethereum address to one of these e-residency certificates. And so you can have Ethereum applications that use Estonian e-residency as a form of ID. So there is self-sovereign identity. There's a project called Uport, which is doing exactly this. I would say Uport at this point is the most advanced, but there are other smaller ones. So last week I met one that's working on something similar to this in Africa. There was one in Singapore that's working on it specifically for the KYC bank use case. There is one in Hong Kong. So it's an approach to identity that is getting an increasing amount of traction. Supply chain tracking. So this is another use case for blockchain technology that's completely outside of the financial sphere. So the idea here is you use blockchains as a way of recording when particular supply chain events took place. When a product was created, when control of a product was turned over to another company, when a product arrived at some destination. And the idea is that if you have this kind of tracking at every step on the chain, then at the end of a chain you have a kind of cryptographic proof of where that individual item came from. If something went wrong, then you can search through the cryptographic proofs and you can find basically where the break in the links was. In the case of the IoT registry, so the idea here is there's this company called Chronicle that's doing this on Ethereum already with shoes. So the idea is that you have a blockchain-based record for every shoe that proves that that shoe is authentic and that it's not fake. Now, why is this on the blockchain? Theoretically, you could just have cryptographic signatures. The reason why it's on a blockchain is because blockchains create these kinds of records that can't be copied. If you just have a cryptographic signature, well, you can just copy it, or you can take a sticker and you can copy it over thousands of times. With blockchain verification, you can actually create a kind of sticker where as soon as someone does the verification process, it automatically sends a transaction to the Ethereum blockchain, and basically that one particular sort of digital identity for the shoe is consumed. And if someone else tried to copy that identity and use it multiple times, then the fraud can be very easily detected. So this is already live, already being used for actual shoes today. BHP Billiton, so this is the largest mining company, like actual physical mining for minerals. They're also starting to use Ethereum for supply chain for tracking minerals. So IoT payments. This is where we start to get into what I call semi-financial applications of blockchains. So applications that combine together aspects of using the blockchain for money with aspects of using the blockchain for things that are not quite financial in nature. Basically, the kinds of use cases that we see with shoes. So there's the same company, Chronicle. What they have is they have an Ethereum-based drone package delivery system. So a lot of people these days are starting to get interested in this notion of using flying drones as a way of quickly delivering products. So what they have is a solution for, first of all, actually verifying that every step of the delivery chain was done correctly. But second, IoT payments. So if, for example, a drone needs to charge at some charging station on the way, then it could make a micropayment and it could charge automatically. If some drone needs to make any kind of payment, if he wants to rent a drone, if he wants to economically interact with drones in any way, then you can use blockchain-based payments to do that. Drones are just part of the story. You can also use blockchain-based payment systems for doing things like bike rentals. You can use them for potentially very many different small-scale payment applications. Computation markets. So the idea here is basically a form of cloud computing that can be verified. So right now, if you have some computing task, then what you could do is you could rent some amount of computing time from some particular provider, and then that computer runs for some amount of time, runs a few trillion, a few quadrillion computational cycles, and eventually returns back to the answer. Now, a couple problems here. One of them is that it's centralized. Now, the fact that it's centralized isn't that bad by itself, but it does mean that there's a bit of lost potential here. So if you look at even this computer, even just like any regular computer that today, there's a lot of unused computing power, a lot of unused hard drive space. And right now, that power and that space is doing nothing. But what if we can create decentralized markets where basically Airbnb for your computer? And if someone has some storage task, some computational task, and if you want your computer to participate in the system, then you can automatically do a kind of negotiation and say, this computer will do some particular storage task in exchange for some payment of 0.5 cents. So on blockchains, this is something that can happen. Now, one part of the story here is payments. The other part of the story here is verification. So what if some computer provided the wrong answer? Now, it turns out with smart contracts, what you can do is you can actually create a form of trust-free escrow. You can create a form of escrow that basically says, if one computer provided some answer, then, for example, other computers have the ability to challenge that answer. If they challenge it, then the computation is actually done on the blockchain directly. And if any participant acted in some way where they can maliciously interfere with some computation, then there's cryptographic proof that they did it, and they can be kicked off the network. So this is something that can be done with smart contracts, can potentially be done today. And like Poland is one project based out of Poland that is trying to do this. There's also markets of similar projects that are trying to do the same thing with storage. So still fairly early, but still something very interesting that's being worked on. Energy trading. So here what you have is basically blockchain-based markets, and in this case, blockchain-based markets for trading electricity. Now, electricity is interesting because it's something that, first of all, it's not just a simple product. Electricity in one place at one particular time might have a different value from electricity in some other place at some other time. Additionally, electricity is a market that's getting increasingly decentralized. 20 years ago, coal plants, nuclear, oil, well, that was basically almost the whole story. Now, because there's an increasing amount of interest in protecting the environment, not killing trees, not trying to warm the globe so much. One of the side effects is that forms of energy production, like solar and wind, that actually are naturally more decentralized, are starting to become increasingly popular. Now, what problems do you have when you have a market where all of a sudden it's not just that you have a million buyers, but you have a million buyers and a million sellers? Well, you need some kind of infrastructure to manage the market. And some people believe maybe some blockchain-based solution to be part of the story. So these applications are still probably a few years away. There have been a few pilots. So for example, in Brooklyn, there was this project called LO3, and they've done a few test transactions where they've managed to sell some electricity over Ethereum. Grid Singularity is based in Poland, or sorry, Serbia rather, and they're trying to do this, but for them it's much longer term. They're actually trying to get like Serbian mainstream electricity producers and regulators on board. So some of these applications still have quite a long time before they get that somewhere. But at the same time, there are other applications that actually are starting to be used right now. In the case of identity verification, there's one in Africa that already has a few users. Corporate governance, Autonomous already has over 100 companies that are on top of it. If you look at some digital assets on Freedom, people are already trading digital tokens today. And a lot of these other tokens are coming around the corner. Look at some of these blockchain-based markets. Some of them exist already. Keyboard, not quite released yet, but it's actually getting pretty close to it. Supply chain tracking. This is something where PHP Militant is already using it. Chronicle already has shoes on the market that are verified using Ethereum blockchain-based certificates. So what I'm saying is that all these blockchain and Ethereum applications, they're not just proof of concepts anymore. A lot of them are still proof of concepts, but we're at the point where they're finally starting to become real. And I think that over the next year or so, by the time we get to the end of 2017, we'll see. The industry is going to become much better. Thank you.
I have a question related to blockchain technology. Many existing Bitcoin companies are using special piece of hardware to accelerate blockchain. Is that a requirement for other applications that you talked about today?
So the specialized hardware that's being used in Bitcoin called application-specific integrated circuits, that's just for Bitcoin mining. right? And mining is only one small process of running a blockchain. But even most Bitcoin users, they don't mine. So it's like you can think of it more as a low-level utility kind of role than something that absolutely everyone needs to do. In the case of Ethereum, you actually don't need specialized hardware to mine at all. GPUs are fine. But like no matter what blockchain you're using, actually in general, using just regular commodity hardware is relatively fine because like in most cases, all it needs to do is verify transactions and send transactions. I mean, that said, potentially there may be a role for hardware acceleration in the future, especially when we start to develop blockchains that try and like target higher levels of performance. And in those cases, I think like the other big one is if your applications require newer forms of cryptography, because many newer forms of cryptography require a very large amount of computational power in order to use. So I think in some situations, there definitely is a place in the ecosystem for specialized hardware acceleration. But that's still something that is going to take maybe like 1 or 2 years.
Thank you. The second question is, what are the challenges that you see for Taiwanese company to embrace blockchain?
I mean, so first of all, I think that Taiwan actually has a lot of potential. And the reason why I say this is that I did my usual Ethereum developer training course in like just a 2-hour workshop in Taipei 2 days ago. And just the level of feedback, like the level of questions and answers and interaction that I got is probably the highest quality that I've seen anywhere in Asia. And like in general, I actually believe that the kind of creativity and the kind of sort of bottom-up thinking that you need to make successful blockchain applications and do successful blockchain research is present here, but much more than it is in most other countries within 5,000 kilometers of here. But as far as challenges go, I think I mean so far like there aren't any serious blockchain applications that are live yet. And so the first challenge is actually searching for one and finding something that it both provides value and is practical and can be implemented. So that's a kind of market research and business problem, and I mean hopefully people will be inspired to try to look for those applications, and if they see something they think is interesting, try to make a business around it. Second, I mean, regulatory challenges, I think, depending on the application or what it needs to be resolved. So, I mean, I'm happy to hear that the Taiwan government is interested in sandboxes. I mean, the third thing is, I mean, in general, just like continued education and continued kind of outreach on the development side. Because in order to build applications, you have to have developers. And finding developers is like the hardest problem in almost every country in the world right now for these kinds of applications. And this is something that I think like it would be good if the Taiwan blockchain community can really actively work on this and hope would grow number of developers substantially over the next year. And I mean, I would say that successful blockchain developers, they're not just people who work for companies and write software for 8 hours a day and that's it. Like the best blockchain developers that we see in other countries are people who get excited about the technology, get interested in its potential, and like even individually start creating various different kinds of blockchain projects. Like there's developers that just by themselves create things like identity solutions, things like utilities for developers, programming languages, and like that's some. But the thing is that this is a very new industry, and very new industries necessarily require that kind of original thinking, and that's something that I think is also a sort of fairly important to promote. And I would say that's probably true in every country.
Welcome to Taiwan, Vitalik. And as we could see, when third-party payment are more and more popular in this world, what do you think about the future of Bitcoin?
I think Bitcoin is something that has many different kinds of applications. So people use it for just like low-value payments. People use it for international payments. People use it even outside of payments as a form of investment or as a store of value. So I think it's something that has multiple value propositions, and like traditional payment solutions, I don't think they're going to be able to necessarily cover all of them. Like the fact that you can use cryptocurrencies to send money from anywhere to anywhere in the world within 20 minutes is something that I think realistically traditional payment systems will still need to take some amount of time to get to. But at the same time, I think it also depends on the region. So, for example, I would say that just simple payment use cases are going to be less successful, for example, in China than they will be in the US, because in China you have paycheck payments and it works well. Whereas in the US, like a lot of payments that there is PayPal, but PayPal charges high fees and it's terrible. There are credit cards, but they're not as convenient. And like it doesn't have existing systems don't quite have the same level of efficiency yet. So I think the ability for like payment applications to succeed does depend on what the competition is. But then I think that like in general they are going to catch up. And if you want to have a blockchain-based payment application that has long-term value, you need to figure out what sustainable value it has, and where I think a large part of the story necessarily needs to be something beyond value transfer.
Hello, thank you for introducing us various blockchain applications. My question is, I noticed that there are a lot of private chain, public chain, hybrid chain. How these chains talk to each other? Thank you.
So blockchains talking to each other is actually something that a lot of people are very interested in, and it's actually something that's quite feasible to do, because one of the benefits of blockchains is that they're a kind of medium where every single operation that happens gets this kind of cryptographic audit trail. And so having blockchains be able to talk to each other and interpret each other is even in a trustless way is something that can definitely happen. So in the case of Ethereum, there is an application called BTC Relay, where Ethereum can verify that a particular Bitcoin block was confirmed or that a particular Bitcoin transaction took place. And you can use this to do things like decentralize Bitcoin to Ethereum exchanges. So it's one small piece of technology, but that's something that could potentially be repurposed to, let's say, move between Ethereum and some other public blockchain, or go between Ethereum and even consortium or private chains. So creating the infrastructure for different chains to talk to each other, especially when you have a blockchain like Ethereum that has a fairly powerful programming language inside it, is something that is definitely doable. I think the challenge right now, though, is that it's still very early, and so we don't have that good an idea of what kind of applications there's going to be that will actually require blockchains talking to each other. And so even though we need to do a lot to build out the low-level infrastructure, in order to build higher-level things, we need to first understand the use cases.
Thank you for your inspiring speech on blockchain. And I think the question for the university aspect is more, what kind of skill set you think should be developed? As you said, finding developer is one of the most important challenges, maybe in the countries. And from universities and from the talent development viewpoint, what kind of skill set you think must be done in the university, in the college, and making sure we have a good pipeline of talent to become developers in the future?
I think that a few things. First of all, becoming an effective developer for extensive applications requires knowledge of computer science, requires kind of an understanding of both the ability to program, but also the ability to theoretically understand what you're doing. On top of that, I think it does require a lot of kind of very generalized skills. So including understanding things like math. If you're building publishing applications, then knowing game theory is pretty much essential. Knowing in various branches of computer science like cryptography and basically fault tolerance theory. I would even say that having an understanding of both those kinds of pure fields and actually having a deep understanding of some particular industry that what kinds of needs there are in that industry that blockchains could potentially improve upon. So those are probably some of the more important building blocks. But then on top of that, I also think that it's important to have explicit training programs that actually do focus on blockchains particularly. And this has happened. So for example, in the University of Maryland in the US, even back in 2014, there was actually a course that was being run by a few researchers where the course basically was about Ethereum smart contract security. And so the professors would write Ethereum smart contracts, and these smart contracts would actually have a few bugs in them, and it would be the job of the students to find what the bugs are. And this is something that happened for about 4 or 8 months, and this was really cool. And I think led to, I know some of the students are still doing interesting things in the space. So I think it's a combination of having the general background and understanding the specifics of working with the environment.
It's really encouraging that you have a lot of good things to say about Taiwanese developers community. I'll be interested in knowing, in order for Taiwan to become a major player in the world blockchain ecological system, can you give us a random, a money list? What are the positives and the negatives in making the dream that we have?
So I think one of the major positives is that I think Taiwan really does have the right culture to participate in this kind of in this industry that is, as I've said, inherently bottom-up in a lot of ways. And for example, when I visited China, I remember there was one point where we were trying to arrange a collaboration with a university. And I was telling them that there are researchers, in places like Israel and places like Cornell that just become interested in these kinds of technologies and start researching things about blockchain protocol design, and eventually even start coming up with ideas of how they can make blockchain protocols better, and then slowly form organizations over time. And I was telling the professors about this, and they said, yeah, in China things don't work that way. And instead, they basically wanted our partners to donate $1 million so they can hire a few employees and make an institution. That doesn't work, right? So I think an approach that actually emphasizes people individually becoming interested in technology and just out of their own initiative, out of developing things and coming up with interesting ideas is, I think, essential if you want to become at least a hub of blockchain technology development. And I think that just from my views, even looking outside of the workshop, even at people like Oshun Tong in your government, for example, I think there is substantial potential for that. That said, the other thing is I think there are different kinds of blockchain hubs. There are financial hubs and there are application and technological development hubs. I think there is potential for the application and technological development direction. I think that's in that direction, what you basically need is you need people that are willing to build things and people that are willing to kind of think about old problems in new ways and come up with ideas like doing these sort of mutual insurance on the blockchain, for example. As far as becoming a financial hub is a bit of a different situation. It's something that requires you to have kind of existing connections to financial institutions, requires people to already be requires a lot of investment, requires the sort of having the same situation as something like London has, and that's a bit more, I would say, maybe a bit more difficult to replicate here. But on the technological side, I think having more collaborations with universities, even having courses inside of universities that try to really talk about this blockchain technology, even dig fairly deeply into how it works, is something that can help to move things forward. And then, I mean, from there, hopefully people will understand things enough so that we can start to get people who are actually capable of building these kinds of blockchain applications that can go from there.
Thank you for your excellent and intellectual speech, Mr. Vitalik Buterin. 感谢 Mr. Vitalik Buterin 精彩的演讲。本中心特别准备一份精致的纪念品要送给我们的演讲贵宾。现在请就中心王主任上台致赠纪念品。王主任知道 Vitalik 很喜欢台湾，所以特别致赠以台湾的伯鸟蓝雀为主题的法兰瓷花瓶给 Vitalik， 也希望他可以常常回来台湾。结束前，让我们有请金融科技研究中心王丽玲主任为我们致闭幕词，有请主任。
非常感谢大家今天过来。我想今天来是希望让大家知道说，政大开始有这样的一个平台。那这个平台想要做什么事情？那我觉得这个平台不是属于政大的，就像我刚刚讲的，这个平台。是一个跨院、跨校，甚至跨产业，是属于台湾的，是属于台湾金融市场，是属于台湾金融 FinTech 产业的。那只有台湾的这个 FinTech 产业可以落实往前走，我们所有的努力跟目标才能实现。所以我们非常希望说，透过大家的努力，我们一起在这个平台上看看可以做什么。那也很希望说，你们如果有什么想法跟建议，或者是说你们看到我们这样的一个组织架构，你可以做什么？可以给我们一些更多的一个建议或启发，甚至来当我们的研究员、当我们的顾问、当我们咨询员，我们都非常感谢。那今天真的特别感谢大家，也特别感谢我们的 keynote speech Vitalik 的演讲给我们很多的启发，包括我相信学术界的人应该想想看，台湾怎么在 FinTech 的研究上，尤其是理学院的老师、商学院的老师。我们怎么样做更 advanced 的研究，然后可以回馈到产业？那我们也希望未来会有很多的活动可以再看到大家。那希望如果我们有办活动的时候，大家都可以来参与。那这样子的一个知识平台，可以让大家用最快速、最有效率的方式得到 FinTech 的知识、技术跟人才。那我们只要有技术、人才跟知识。我们台湾的 FinTech 产业才能继续往前走。谢谢大家，谢谢。谢谢王主任。
国立政治大学金融科技研究中心开幕典礼及专题演讲活动到此圆满落幕。仅代表研究中心感谢各位贵宾热情的参与。未来中心将继续努力，各位的支持是中心继续前进的动力。我们期待下次再会，谢谢。